because that's me, right? I don't do the main street. So, because exactly, and I'm glad that you understand. It brings me great joy because it means that everything that I did in high school has been like, well, no, it has been. What's the word I'm looking for? Has been relegated. Not the right word. Has been. Nope. It's not. Anyway, yeah. So if Jack was in third class, it makes sense that he's the one that died and Rose lived because there's only a 10% chance that Rose was gonna die. So. Yeah, and bringing up that's a great point. Why is it more likely for the third in the crew to die? Well, they didn't care about them, but not by much though. I mean, well, I guess there was a lot more crew. But where was the crew? Somebody just said it when they were talking about where Jack got locked down. Where were they?
Because they were in the thing.
They were on the bottom of the ship, right? And so to get off the boat, they would have had to have made it up so they can get on a lifeboat because the part of the ship that they were on was already underwater. And so when the boat crashed, if they didn't make it out of those bottom rows, those bottom levels, they were already in the water. Like there was nothing they could do. So I don't know if it's so much that they didn't care about them, but the crew of the Titanic, like any luxury boat, is made not to be seen. And so they're in the bottom, and when the ship crashed, they couldn't do it, right? Okay, so this is looking at row percentages. How does ticket class change between survivors? So we're looking at alive to dead, and we're looking at these changes. And it's clear that being in the crew was worse than being in first class. Okay. There's a chart, side-by-side bar chart, of alive versus dead. So there's your living members, your dead members, living dead, living dead, living dead. It's clear that in the crew and in third class that we had significantly more dead people in those classes than in first and second class. More of first and second class lived than these ones. So let's switch it. Let's switch the way we think about the problem because it's good to think about both. How does survival change based on class, right? Before it was how does class change based on survival? This is how does survival change based on class. This is looking at column percentages. In other words, we're using the same numbers here, right? Notice that those numbers are the same as the previous graph. But now when we're counting the percentages, instead of comparing 203 to 711, we're comparing 203 to 325. Okay? So we have a table full of column percentages now. And again, we can look at it based on, and we can look at this table and try to see some of those differences of how it changes by class. One thing that's not shown on here, and it really should be, is the percent down here. This is all 100% now. Right? All of these are 100%. Because 62.5 and 37.5 add up to 100%. So how do we look at this one? Well, we can pick a class. Instead of looking at the alive row, what we're going to look at is the first class column. So analyzing first class, 62.5% of first class lived and 37.5% of first class died. 41.4% of second class lived, 58.6% of second class died. 25.2% of third class lived, 74.8% died. 24.0% of the crew lived, and 76% died. Is it better to be in the first class, second class, third class, or First class had a significantly better living rate than the crew had. Third class and crew, any major differences? No. So it's better to be first class, but whether or not you're third or crew, not a huge difference, because those two numbers are pretty similar, right? You had a fairly even chance of dying whether you were third or crew. And again, they were on the bottom parts of the boat. Why? Second class actually didn't do too well. Less than half of them came out alive. 41.4% of them came out alive. 58.6% of them died. So while it's better to be in second class than it was to be in third or crew, it's still not fantastic. The only people who really made it out of the Titanic reasonably well was first class. But looking at the differences between row and column percentages can help us see that. In row percentages, it didn't look like second class did all that bad. But when we look specifically at just the second class members, it does look like they did not do particularly well, right? 41.4% lived. First class are the ones that really made it out of there alive, and that's probably because first class had a lot of money and were able to be on the top of many places and get the lifeboats on time. They were the first ones out. Questions, comments, concerns, column percentages? The way we look at the data makes a difference. All right. There's a side-by-side bar chart for that. By the way, sometimes when I say bar chart, I say bar chart. The guy that I learned this from initially when talking about bar charts was from Boston. So yeah, I just can't help it sometimes when I'm saying bar chart, I say bar chart. Bar chart. I'm gonna look at this bar chart here. And again, those are just the same numbers of what we had before, right? You can see significant amount of third class and crew dead. Second class, not that fantastic. First class, I mean, 60% still not a great survival rate, because that means 40% of the people are dead. But it's better to be rich than it is to be crew in terms of not dying. I mean, in general, that's probably a pretty safe statement. Yeah. But listen, rich people have problems too. Right? What happens when their Rolls Royce breaks down and they got to drive the BMW? What does that do to your reputation? It's true. I don't have money. I don't know what to do. Okay, so now the big question here. One of the biggest ideas that comes out of this chapter is this idea of independence. This is one that I actually end up thinking about a lot when I'm looking at personal statistics of whether or not something's good, whether or not, what am I trying to say? Well, I'll describe it in a minute. Let's talk about what independence is first. Independence. Variables are independent of each other if one does not affect the other, right? That's what independence means. It means that one thing is not affecting the other. Right now, the bulk of you are probably you're called dependents, right? In terms of life, you're called a dependent because a lot of what you do relies on your parent or guardian, right? Some of you guys are seniors. You might be in a place where you're buying your own food and paying rent and that kind of thing. That does happen. But I'm betting that the bulk of you eat the food that your parents buy for you, right? You're dependent on them. If your parents bought pizza, you're eating pizza. If your parents bought stroganoff, you're eating stroganoff. You're dependent on them. Your actions, your food depends on what they buy. The moment that you were independent, your parents are buying stroganoff, but you're eating hamburgers because you're independent of them. Their decisions don't affect your decisions. Same thing with variables, right? We're talking about when two variables are not affecting each other, they are considered to be independent variables. this becomes a very important concept because when we're comparing two variables, categorical variables, being independent a lot of times will tell us a lot about the world. For example, if you a lot of ways that I tend to think about independence is when I look at statistics about race, right? One of the let's bring it back to Donald Trump because Donald Trump is just so fantastic at making terrible statements. Donald Trump made a statement that illegal immigrants cause crime, they're rapists, whatever it was that he said, right? And he said that there was all kinds of data that backed this up, that it was like 15% of crime is done by illegal, or something like that, right? I don't remember what it was. We can bring up the actual statistics if we want to, but there's this question of independence. If a certain percent of the population is an illegal immigrant, we would anticipate that they would have approximately the same amount of crime, right? So what I'm saying is, if 10% of the population is an illegal immigrant, then we would anticipate that 10% of the crime would be from illegal immigrants. Does that make sense? Because they're 10% of the population, we would expect them to have 10% of the crime, right? If African Americans were 25% of the population, we would anticipate that they would have 25% of the crime, if we're looking at total numbers. If 75% of the population is white, we would anticipate that 75% of the population, the white population, we try to get 75% of the crime was caused by white people. Does that make sense? Because they're those totals, we would anticipate that those things would be the same. If they're independent of one another, we would expect them to be the same. Dependence would mean that there's a difference. And what happens is that the amount of crime that's being done, the reason why Donald Trump is so wrong, is the amount of crime that's being done is by illegal immigrants is far less than the percent of the population. There's no independence there. And so we have this problem where we would say, well, there is a dependence. The likelihood is if you're an illegal immigrant, you're less likely to cause crime. Whereas if you are, if you're white, you're more likely to cause crime because they have a percent of crime done by white people is higher than the population of white people. So we would anticipate, so there's this thing, because more percent of the crime is done by a smaller point of the population, we have a dependent relationship. So when the percents are about the same, we would expect independence. One does not affect each other. But when they're different percentages,